In this video, I'm going to create the Windows Network Load Balancing cluster that will provide high availability and load balancing for my Exchange 2010 Client Access Server array. The first steps are being performed on the first one of my Client Access servers, SID EX1. So in the Start menu, go to the Administrative Tools and launch the Network Load Balancing Manager. From the cluster menu, we're going to choose to create a new network load balancing cluster. Now first we need to specify at least one of the hosts that we intend to be part of the cluster. So I will specify SID EX1 and connect. And next we just need to choose which of the interfaces will be used to form the cluster. So in this case it is this interface that I renamed to NLB. These default host parameters are fine. You don't need to change anything on this screen here. Go ahead and click Next. And now we need to add at least one cluster IP address. So this will be the IP address that the fully qualified domain name of the CAS array will resolve to in DNS. And it is the virtual IP address that is used to load balance traffic between the two NLB cluster members. So on my network, I'm going to assign 192.168.102.10 So when you've added your IP address in, just click Next to continue. Next we need to configure a few more parameters. The first being the full internet name of the cluster. And just for simplicity's sake, I'm going to give it the same name as my CAS array. We also need to choose the cluster operation mode. Now to understand just at a basic level what each of these operation modes do, I'll just refer you back to the earlier lesson on Windows Network Load Balancing concepts. In your test lab it's probably not going to matter which one of these that you choose, but if you are deploying Windows Network Load Balancing in a production environment, you will want to make sure you choose the correct one of these to suit your environment, to suit the networking configuration and the networking hardware that is available for you. But as I said, in this test lab environment, it doesn't make too much difference, so I'm just going to leave it on unicast. The next step is to configure the port rules for the NLB cluster. Now, if you did nothing at all here, this would actually work. All traffic on any port would basically work through the network load balancer, and you wouldn't really have any issues. But in a production environment, you'll want to be a little bit more specific with these port rules. So I'm going to demonstrate that now by removing the default rule, and we'll add in some more specific rules for particular types of traffic. The first is TCP port 80, so some web requests that occur over HTTP. We also want 443 for web requests that occur over HTTPS, so those that are secured with SSL. There is also port 135 for RPC or MAPI requests. And finally, we just need to allow a high port range for the dynamic RPC port mapping. If that high port range seems large to you, there are ways that you can configure more restrictive ports, and that's sometimes required when your clients are connecting through firewalls to reach your client access servers. But in this test lab, at least for now, we'll just use that high port range as you see there. Now there would be some additional ports if you also intended to use this network load balancer for other protocols such as POP and IMAP, but I'm just going to exclude them from the configuration at this time, and we'll just continue on with just the rules that are required for Outlook and the basic web services. So if we're happy with those port rules, we'll go ahead and click Finish. and Windows will go ahead and configure that network load balancing cluster for us. And the end result is a network load balancing cluster that only has one server as a member of it at this time. It's fully converged, all that configuration is complete. So now we just need to add our second server to become a member of that network load balancing cluster as well. So here in the cluster menu, click on Add Host, and I want to add SID EX2. And again, we're using the network load balancer or NLB interface name as the one for this network load balancing cluster. There's no need to change any of these default parameters. We don't want to make any modifications to the port rules at this time, so just go ahead and click Finish, and then we just wait. And after a few moments, that configuration change is complete, and now we have two nodes in the network load balancing cluster, and they both have a status of converged. So after establishing that Windows network load balancing cluster, we now need to update the DNS record for our CAS array to point to that new virtual IP address that is used by the network load balancing cluster to load balance and provide high availability for traffic. So we'll just go in here on my domain controller to the DNS manager console and update the IP address of my outlook-sid.exchangeserverpro.net DNS record, which is the one for my CAS array, and change that from being 192.168.102.11, which is the network interface of SID EX1. We'll change it over to 192.168.102.10, which was the IP address I assigned to my network load balancing cluster. So now back on my test PC, I can test that change and see if it's taken effect by pinging the name of my CAS array. And that's returning the correct IP address now, 192.168.102.10, which is that virtual IP address configured in network load balancing. You may need to clear your client's DNS cache if it doesn't immediately return the right response. Okay, so Outlook has opened successfully. It's connected to Microsoft Exchange, and because it's resolving Outlook-SID to the virtual IP address, it's connecting through that Windows network load balancing cluster. Now I'm going to test the high availability of my client access server array. So here on server SID EX1, I've just used perfmon to bring up the MS Exchange RPC client access active user count metric, and that's showing that I currently have one active user connected to this server. And that's the user that I've got configured here, Alan Reed, connecting in this one test PC. So that's the only active user connection in my entire environment. And currently the load balancer has distributed that to SID EX1. Over on SID EX2, the same counter, we can see there are no active users. So if we know that the client connection is going through SID EX1 at the moment, let's see what happens if we shut that server down, basically to simulate a failure. I'll go over to PC1 and also start a continuous ping. So we've got the ping running, it's responding, and Outlook is saying that it's connected to Microsoft Exchange. Pop over here to my Hyper-V console, and we've got SID EX1, and I'm just going to go ahead and turn it off. I'm not going to gracefully shut it down, I'm actually just going to power it off completely. Okay, so that's powered off very fast. It wasn't a graceful shutdown, and now my connection's being completely lost. Have a look over here at my PC. That continuous ping is still running, Outlook is still connected to Microsoft Exchange. And after refreshing this report, I can see I now have one active user on SID EX2. So even though SID EX1, which did have the active client connection, went down unexpectedly, it powered off. The ping was not interrupted. The user's connectivity to Exchange via Outlook was also not interrupted. So there we have what is a highly available client access server array using Windows network load balancing.